I'm gonna share screen again. All right, so we are recording again. Yeah, we're recording, yes. And I'm sharing again. So suppose we put this circuit like this. So I'm gonna use some simpler circuit now. All right, so these three resistors now. If I connect these three resistors like this, what type of circuit is that? Series or parallel?
Yes, sir.
Huh?
Back. I'm back.
It's a
Yeah,
series circuit, don't it?
but it's kind of sound low. The
Oh,
camera.
sorry about that. So if I connected these resistors like this, what are they? Series or parallel?
Series.
Series. All right. Do another thing to find out something to see how many thinking. All right. And if I put a battery on it, like this, and like this. How are the resistors connected? Series or parallel? Hmm?
Traffic about on load, brother.
All right, they are connected in series parallel. So we have two of them in series. We're gonna label them R1, R2. So we can label them right here, but this one and this one is in series, and this one is in series. So both of them are in series. They are this is in series. These are in series, but you don't put a voltage on it, it become a parallel. So right now the circuit is known as a series parallel circuit. Let me show you what I mean. If I should let me use a multisim just to get a better idea. So multisim is coming on. Yes, it's gonna populate. So I'm gonna put on some resistors on the circuit now, but I'm going to use the resistor symbols. The symbol for resistor is this big G. So if I have this resistor right here, I'm gonna catch another one. This one, put one right here, and put another one right here, and close that. If I join these two together, what are they? Series or parallel? They are in series, don't it? Hello? Hello, students.
Yes, sir.
All right. So if I join these two again, they are in series again, don't it?
If yeah.
So these two are in series. These
Yes,
two are in
sir.
series. They're supposed to join this one to this one right here. And this end
Series parallel.
to this end. Right now, it's in series parallel. If I get my tester, and I should put on it, I'm supposed to get a reading. Notice that I don't have the voltage on the circuit. So I'm just testing the total resistance. So what do you expect the total resistance to be? 1,000 and 1,000 is 2,000. 1,000 and 1,000 is 2,000, don't it?
Yes, sir.
So 1,000 times 1,000 divided by 1,000 plus 1,000. How much I get back?
1,000 times 1,000.
Divided by 1,000 plus 1,000.
500.
500. All right, good. Now this resistor right here, which is 1K. This is 1K, so this is 1,000. No, this is 2,000. And this is 2,000. If this is 2,000, this is 2,000. What am I supposed to get back? 1,000 or 500? Which one of them?
1,000.
1,000. Oh, you know it's 1,000.
1,000 times 1,000 divided by
By
1,000.
2,000. How much I get?
Right. Plus 1,000 equal 1,000.
Get back 1,000.
Yeah.
So we're going to look at the resistor, the measurement, and we're going to check it.
The one there 5
Okay, not a
bills.
ground.
No, the one we're doing now is 500 on there.
Say it again?
The one we are doing now, the 1,001.
Yeah.
It would have been 500.
It will be 500.
Yeah.
Why would it be 500?
No, 1,000 times 1,000 divided by
Right. And I told the time I told you give how much.
1,000,000.
All right. 1,000 multiplied by 1,000, and then that divided by 200 give how much?
But I don't buy 200 or 2,000, sir.
By 2,000. Right. If you divide by 2,000, how much you must get back?
500.
No, sir. 1,000. Think about it. 1,000 times 1,000.
It's a million.
Let me bring up my calculator. I'll let you see something on my calculator. It is 1,000 multiplied by 1,000. divided by 2000. What's I get? 500? Show it 500?
Sir, that will tell us, sir.
Okay.
Earlier.
So only one person respond. I wanted to hear the other persons to see if they're following. All right.
Yes, sir.
So look at this now then. This is 1,000 right here. This is 1,000. So this is 2,000. If I should use this as one resistor right here, I'll get 2,000. If I use this right here, so again I'll get 2,000. Note it.
Sir, they're break up a while ago.
I break up a little while ago.
Yes, sir.
So when I run this, I'm getting 1,000. Why am I getting 1,000?
But now I need to get on.
I get 1,000. Why I only get why I get it like that?
But probably where you put the wire.
All right. So I'm gonna stop it now, and I'm gonna do something different again now. I'm gonna use 2 resistors this time. Put one right here. I'm gonna put another one right here. I'm gonna change this to 2,000. And change the other one to 2,000. All right. And I'm gonna join them now in parallel. I'm gonna use a nanometer. Test this. So this one, this meter is for that over there. This meter is for this one. If I put a tester right here, I put a tester right here, I'll measure both of them. I run a simulation. I get 1,000. So why do I get 1,000? What should I do to get the 1,000? Should you say 1,000 multiplied by 1,000? By 1,000 plus 1,000? Or do you work out that?
Resistance, yeah, calculate, sir.
Yeah, look at this. This is what? This is 1,000, don't it?
Yes, sir.
And this is what again?
1,000.
So it become like what? One resistor, don't it?
It'll come like a 2,000 resistor, yes.
2,000, yes. So if this is 2,000 up here, so this is 2,000 down here, so what's the total resistance? Still 500?
1,000.
1,000. Did you see what was wrong? Why you get the 500?
Sir, that one.
I calculate it. I calculate it according to what you want.
No, sir, you calculate the series with the series parallel formula.
And what, how should you calculate it? What should you really have up here? Talk to me. In the calculation, what should I put? 1,000 or 2,000?
2,000.
2,000. What should I do again now? Multiply it by what?
2,000.
All right. So I clear with that. And I divide now by how much?
2,000.
2,000.
No, 4,000. 2,000.
4,000?
No,
Okay.
2,000.
2,000. All right.
2,000.
And if I divide that by 2,000, how much am I supposed to have?
Nah, you get 2,000. That around.
All right. Let me go on again. It is 2,000 multiplied by 2,000 divided. We're not doing it like this. You have to put a bracket. By 2,000. Close back the bracket. Right? What's going on right here, so now? Right. So it is 2,000 times 2,000. Let me do that straight. Hold on. 2,000 times 2,000. I get what's this figure right here?
4 million, sir.
Right. All right. What is 4 million right here, so? 4 million divided by how much you supposed to divide by now?
Should get one 4,000, sir.
4,000? Why 4,000?
The how much the register the multimeter register?
Why 4,000? Why I must do it by 4,000? There's a 1,000, but why you do it by 4,000? You remember? It's 2,000 plus 2,000.
2,000 plus
Yeah,
2,000.
remember the equation R1 multiplied by R2 divided by R1 plus R2?
Yes, sir.
That's the equation that they use and get it. So we're gonna go back to the
So you
multiply.
multiply all I R them,
Huh?
add the all I R them, add
Yeah,
the,
all right. You see
the
these two up here, so
yes, sir.
these two become one, like this. These two again now become one again, like this. So this circuit is equivalent to this circuit. So if I reduce this circuit to this, I'm gonna get R1 and R2, don't it?
Yes, sir.
Evaluate, you're looking at R5 or R6. Yeah. If I say this R multiplied by this R, divided by this R plus this R, that's what I did to get the 1,000. You understand? So it is 2,000 multiplied by 2,000 divided by 2,000 plus 2,000. You see it now?
Yes, sir. Yes, sir. I see it.
All right. So we're gonna be measuring some current now. Usually when I'm measuring the current, let me just take off all of this a little bit because the time gonna run out shortly. Oh, it's time to turn off now. All right. So I'm gonna do something fast. I'm going to do it with the simulator and then I'll do it with the Tinkercad. All right. So we're gonna get one resistor and you're gonna tell me what to do after I do it one time. This one resistor right here, close that. Let it be big. I got this one tester right here, so. All right. And I'm gonna put on a voltage source on it. And the voltage source, I'm gonna put a DC. Yeah, be AC or DC, but I'm gonna put a DC. right? I'm gonna set this meter so that it all right. So the positive of the meter. So I'm gonna put a current. I'm gonna put a voltage on the circuit. The voltage that I put on the circuit is 12 volt, right? So I put 12 volt on the circuit. This is V1, 12 volt, right? So if I should do this in the circuit, I know that a current is flowing in the circuit, don't it? A current is
Yes,
flowing
sir.
to the resistor, don't?
Yes, sir.
If I want to know how much current is flowing to the resistor, I can do two things. I can either calculate it or I can measure it. If I calculate it, what will be the current if I calculate it? It is R over V over R, don't it?
V over R.
And this is the V and this is the R. So 12 divided by 1,000 give you how much? When you use a calculator, 12 divided by 1,000, what's you get? When you use a calculator. 12 divided by
0.012, I think.
how much?
0.012.
I didn't hear that.
I think a 0.1.
0.012.
Yeah.
All right. So I'm gonna put my test on it now. So usually when you measure the current, you have to break the circuit. So I'm gonna break the circuit, and I'm going to put my test on it. All right. So usually when I'm measuring current, I put the positive to the positive part of the battery. This is a symbol for a battery, symbol for a resistor. But the symbol for the battery, the broad part of the battery is the positive part. This is the positive of the tester. And the small part is the negative part. So I put the negative part to the small part, but it goes through the resistor. So if I do this now, and I set a tester to measure ampere or current, because current is measured in ampere, so that's why I press the A. Then I run it, and then you'll get that amount of current. I say the amount of ground, so I'm gonna put on the grounds on it. This is symbol for the ground. And usually I put the ground on the negative part of the circuit. We don't really put the ground on the positive part. Right? So we're gonna run it now. All right. And we get 12 milliamp, 12.001. So what I wanted to do with this 12.001, because it is in milli, I wanted to divide by 1,000. So 12 divided by 1,000 give you how much?
12 divided by 1,000.
Yeah.
0.012.
Right. I remember that's what I get the first time. So this is in milliamp. Right? It's a small fraction of an amp. So instead of say 0.012 amp, you can have say 12 milliamp. All right. So we can just see if we can do it on a Tinkercad, and then we just call it a day. So we're gonna do it on a Tinkercad now. So we're gonna take out back one of these two resistor. We're gonna use one resistor. Right, and we're gonna use this tester. This is a 9-volt battery. And we're gonna use this resistor right here. Are you gonna tell me exactly what I should do when I have the tester? So you come to class Wednesday. I give you a tester, I give you a battery, and I give you a resistor. How do you measure the current? Tell me what to do.
Either connect the battery to the resistor.
All right, so I connect the battery to the resistor. Yes. Mm-hmm. Yeah. So I'll connect the battery to the resistor. And then, where do I connect this part of the resistor? To the negative or the positive?
To the negative.
All right, look at this part of the resistor. This part of the resistor is coming from where?
Positive side.
So therefore, this part must be what?
To the negative.
Positive.
Oh, positive. Oh,
If I put it on the negative, let me show you something what's gonna take place.
arrow.
No, you're not gonna get an error, but you're gonna get a negative. You have to set it for the amperage. See the negative right here?
Okay, sir.
So you'd have to set it the right way. So when you come and I give you the test and the meter, then you do that. So I want to connect this back on the positive. So I'm gonna go around the meter to make it look more uniform. And I connect on the positive. And now I get to connect my negative to negative. You see what's going on?
Yes, sir.
So if I run it now, what's the current that I'm supposed to get now? The amperage I'm supposed to get. What's the value of this resistor?
Um,
Yellow
let's
at
see.
4.
This is red, orange, yellow.
Red, red, orange, yellow.
So red, orange, yellow give you what?
2, 3, 23, 240,
Hmm?
234,000.
134?
Yeah.
You sure? I know that will catch somebody, man. So the red is what? Red is 2, don't it?
Yes, sir.
And the orange is what?
3,
3. And the yellow is what?
4,
So what should you put? The number 4 or 40?
40, sir.
Right. And that will give you how much?
230,000.
230,000. Right. So if you want to find the current now and you want to calculate it, and you want to measure it, you say 9 volt or volt over resistance, so 9 divided by 230,000, don't it? And how much that's supposed to give you?
9 divided by 200 or 230 divided by 9.
9 divided by 230,000.
Oh, yeah.
So how much that's supposed to give you? 0 point too much.
Oh, yes, sir.
0.000 how much?
9 divided by 230,000.
Huh?
That can't right.
You get it yet?
We calculate that shots out or something.
This is
Hold on.
38.6 microamp. Not milliamp, but microamp, which is 0.000391. Or 0.0038. It's right here. All right. So that is it. So when you come to class Wednesday now, you're gonna use a tester with resistor and battery. You're going further now to test current. All right. And voltage.
Yes, sir.
So that is it. Until tomorrow. So I'm gonna see if I can send all the recordings that I have so far. Remember to come on Wednesday. Remember to attend all the other classes.